Greetings and welcome to the video where we're going to work out a practice problem for a dependent t-test. So I have taken the liberty to already kind of pre-populate our Blackboard here with some information. So the first thing is you'll see I've got a data set that is set up in pairs, and we'll talk about that in just a minute. But these data represent pairs of human total body mass measurements in pounds. So we're taking body weight here and looking at the efficacy of a weight loss supplement. So these, essentially this is the person. I'll put this in blue. So this is person. And then this is the kind of the pre-test here, body mass. That's 225 pounds, 241 pounds for person 2, 226 pounds for person 3, so on and so forth. Then they're on some kind of weight loss supplement for a certain period of time, and then we bring them back in and we measure them again, and this is the post-test body mass in pounds. So person 1 went from 225 pounds to 192 pounds. Person 2 went from 241 pounds to 202 pounds, and so on and so forth. And then this D sub J then is the difference score. So if you take variable 1, x1, which is the pretest, and subtract it from x2, which is the post-test, 225 minus 192 is 33. For person 2 and so on and so forth is 241 minus 202 is 39, 226 minus 206 is 20, and so on and so forth. Okay, so I guess let's just define the rest of these three columns here real quick. So this D sub J minus D column, this is very similar if you remember your X minus X bar column when we were doing a variance and standard deviation, taking a raw score from a mean score. Now you're taking a raw difference score, this D sub J, minus a mean difference score, and we're going to calculate this mean difference score in just a moment. And then the next column over is kind of like your X minus X bar squared column, like we have done before. Which is self-explanatory. That would be taking this 3.44 and squaring it to get 11.83, and then this D sub J squared is just taking this 33 right here and squaring it to get this 1089 value here, and we'll show you where this could apply later on. Okay, so that defines our columns at least for us. So what is our null hypothesis? A null hypothesis here is that the mu, and let me just get this back up in Paint here, that our mu, and if you recall, why are we using mu? Because mu is the population parameter and x bar is the sample statistic, and we're going to take samples from our population, compute sample statistics, see if those sample statistics are different, and then infer any of those differences back to the population. So your null and your alternative are always about what's going on in the population, and we're going to try to estimate what's going on in the population with our sample statistics. And so the mu, or the mean here, of the difference score, sub D, in the population is equal to 0. And that makes a lot of sense, right? So if you think back about what that design looks like, you're going to have kind of an observation 1 happening at pre, you're going to have some kind of weight loss supplement X, and you're going to measure them again at O2, and this is kind of the post. And when you subtract these two, what you're saying is that whatever difference score you get is 0, which means that whatever the mean here in 2 is was the same body mass that they had when they were here, and your weight loss supplement didn't work. Okay, so that makes sense, the 0. And then what you're saying for the alternative is that there is some kind of difference score. These two are different from 0, and they're statistically different from 0, or far enough away from 0 that we can consider them statistically different, and that your weight loss supplement had some effect. Okay, so let's kind of just, I guess, go back to the fundamental equation that we're going to kind of be working with here, which was our, our t equals d bar divided by s d bar. Okay, this is the standard error of the mean difference scores. Okay, so let's just start calculating some of these things here. So what is our total n here? So total n is 9. So our new, or our, it looks like a V, our degrees of freedom here, remember that's what new stands for, is n minus 1 for the dependent t-test, n minus 2 for the independent t-test, which equals 8 here. So how do we get then d bar, which is the numerator term? Let's go back to blue here, which is our numerator term up here in our t-test value. So this is just going to be the sum from j equals 1 through n of our d sub j divided by n. In other words, you're going to want to sum the d sub j column. Well, where's the d sub j column? It's this one right here. So we want to sum this guy, and the sum that we get is 266. This is 266 divided by 9 here, which gives us 29.56, and I'm going to put in the units here, which is pounds. Okay. Next term we want to go for is to get that, well, wrong. Got ahead of myself in my mind here. We want to get this variance term for the different scores. You'll recognize this as our variance equation, where we're going to take the sum of the dj minus d bars squared divided by n minus 1. So if we plug and chug this, it is basically summing this column, which when you sum it will give you 520.19. So 520.19 divided by n minus 1, which is 8, gives us 65.02. Now, because we've squared all these scores, our units now are in pounds squared. Let's get another term here for us. Let's go S sub d. So the standard deviation of these different scores is simply just the square root of s squared d, which equals the square root of 65.02, which equals 8.06. Now the pounds, or the units, go back down just to pounds because we're taking the root of those squared units. Okay, so out of this, what do we have so far? We have, going back to our equation, so where's our equation again? Let's just put in a blue rectangle. We need the d bar. Where's our d bar? Our d bar is this piece right here for the numerator. And then what do we need still? We need this standard error term right here. We haven't calculated that yet. So if you remember, that's the standard error of the mean differences, which is very similar to the form standard error of the mean, which was the variance divided by the square root of n. So why did we have to calculate the variance down here? Because simply what we can do now is plug and chug, and we can get this standard error of the d bar term that we need for the denominator by simply, I have written it in another video just to be consistent. We had written it this way. Let me give you the long version first. We take the sum of the d squared, which was, sometimes I push the button on this pen and things go a little crazy. Let's try to get that button out of the way. Anyways, it's this row here. subtracted from that's n multiplied by n minus 1. So anyways, we can reduce this simply to, you could put this piece here is really the dj minus d bar squared, the sum of that column. These are equivalent terms here. So you could reduce this equation to that form if you wanted to, but essentially when you plug and chug the numbers here, what are you getting? The standard error of the mean is taking this 520.19 dividing by n, which is 9, multiplied by n minus 1, which is 8, and then taking the root of that, and you'll get the square root of 7.22, and then when you clean that up and take the root, you'll get 2.68, and this is in pounds. Okay, so if you kind of think back and go back to our questions, what were our questions, our steps? Our steps were basically, I'll just kind of put them up here just for a minute, but our steps in general were what? One was kind of restate, your null and your alternative. I like it in statistical form, so I'll put that out here over in parentheses, and I've done that for you here and here. Your second step was really to determine your characteristics of comparison distribution. In other words, what are your degrees of freedom? Degrees of freedom, question mark. Well, nu equals n minus 1 for a dependent t-test. So our comparison distribution is going to be based upon degrees of freedom, what here? It'll be based on degrees of freedom 8. Okay. Let's probably put another equal sign here. The other thing that we ask you to do is then, step 3 was determine the cutoff that you want to have on this comparison distribution. And your cutoff is t at a particular alpha level. In this case, we're do it two-tailed at a certain new value. And remember, these are investigator chosen. Investigator chosen. So let's just say that you picked T.05 two-tailed with degrees of freedom 8. I'll pull this in as the last thing. It's going to cover up some stuff. I'll pull up a table over to show you, but this would essentially be 2.306. And if you remember what we call this is your critical T, and our calculated T, which is going to come from this up here, has to beat critical T for it to be significant. So what do we have to do? Step 4, we got to calculate our t-score. Calculate our t-value here. So t equals d bar. What's d bar here? 29.56 pounds divided by standard error of the mean difference scores, which was 2.68 pounds. Pounds are going to cancel. We'll get a unitless value here of 11.02. And now the question we have to ask ourselves is, step 5, make a decision. What's our decision? The decision here is that calc t, which is 11.02, calculated t, is greater than critical t, which was 2.3, I'll put these in parentheses, 2.306, and because calc is greater than critical t, we reject the null. We're willing to then challenge this null and say it's probably not that these mean differences could be considered zero. They're really something greater than zero. And if you look at this data, right, we're seeing that they're decreasing here. And so it makes a lot of sense to say, well, we can't consider them as zero. They're either greater than zero in the negative direction or greater than zero in the positive direction. In this case, it's in the negative direction, and that's fine. But you're going to reject the null here, and that is the basic setup. And from here, what we can do is we can go in and say, if we don't want to use more of this. Calc t beats critical t, we can then calculate an effect size. So the next video will calculate just a quick effect size, quick video to show you the alternative method of doing your hypothesis testing. Thanks for watching this video.